I'm going to talk about learning and teaching modern C++, about the challenges we have and the resources available. Let's start with the intro. My name is Arne Mertz. I've been doing C++ for a bit over 10 years, except for the last year where I've been doing mostly Java, JavaScript, project coordination stuff. I've been blogging about C++ mostly and clean code and testing since the start of 2015, basically because the first 7-8 years of my C++ career I have been dealing with old legacy code and people that had this kind of old legacy knowledge, and it was really hard to do all the refactoring to get the code cleaner and to also teach those colleagues a bit of the more modern C++ styles. So this is what the talk also is about. First of all, when we're talking about modern C++, then usually you get 10 different opinions from 9 different people. So what do I mean with modern C++? I like Twitter polls. For example, Meeting CPP has done a Twitter poll about what do you think is modern C++? In 2015, one caveat, there are only 375 votes, so not a good statistical significance. The options were new standards with or without boost, ask Alexandrescu, and using C++ to its fullest, whatever that may mean. So I'll go through the options. The new standards. Like standard documents, do define what is possible, not what you should use and what you should not use. For example, you still can use new and delete, you can use void pointers, you can use C arrays, all the stuff you get from C, because the standard has to be backward compatible. But when I see void pointers and C arrays and some stuff like this in C++ code, I wouldn't say this is modern C++. So just saying use the new standards and nothing more is, for me, is not really modern C++. I've also seen lots of C with classes, like was done, I think, in the start of the 90s mostly. Then end of the 90s, just kind of thinking about we have to do everything object-oriented like in Java, and in Java they actually baked it into the language that everything has to be an object, everything has to be a class. And some people adopted this for C++ and no free functions allowed. With my last employer we had that one. Even if you wanted a free function, you had to create a class and a static function inside it. No free functions allowed at all. So this kind of style, if you just use what is in the standards but have no further restrictions, it will compile. It will be C++ 11 or 14 or 17 compliant. You may even get code that can only be compiled with a C++ 14 or 17 compiler if you use range-based 4 or newer features. But it's not really modern C++. And if you add boost or leave boost out, it doesn't change anything about that the style makes up what is modern and was not. So let's get to the next one, Ask Alexandrescu. Who of you knows the book Modern C++ Design by Alexandrescu? Okay, most of the people, but not everyone. There was a book, Modern C++ Design, by Arne Alexandrescu. It was released in 2001, and it was about really heavy template programming. He was like with C++ 03, where we did not have variadic templates and stuff, using template type lists and kind of policy-based class design and lots of small types to manage behavior of other classes that were templates. It has really influenced how people thought about C++ then, and also influenced the current standards and the current standard libraries. For example, allocators we have in the standard library, well, we had those before, but these are kind of policies, and we have much more. For example, the static assert we have now in the standard was partly designed by Alexandrescu as well. He back then used templates and Swine to get basically the error messages at the compile time if some condition was false at compile time. But that is not all I would say is modern C++ now, because, well, 2001 is 16, 15 years ago. C++ has about 30 years. I think 30 years ago it was the first compiler, C++ compiler. So this is about half the way from then to now. I will still recommend to read that because you get, if you have not done much template programming, template metaprogramming yet, you get a lot of idea if you read that, and you try to solve lots of problems with template metaprogramming. But I wouldn't say it's modern C++. But there is a quote from Andrei Alexandrescu after the poll from Meeting CPP. He did basically a blog post about what is modern C++ and asked Andrei. And Andrei gave this as an answer. The modern CPP design coined the term modern C++. It was obviously not used before. And he says the term refers to this kind of template code he used back then. Okay, if that back then was modern C++, what do we call the C++ we do now? If you look at modern art was the epoch from 1860s to the 1970s. So art that is done today is not modern anymore. After modern art, we got like postmodern art. We have like contemporary art. Let's see what we have in 100 years, because that won't be contemporary art or postmodern art anymore. We have to invent new terms for that. So, if you look at the conference schedule, we have functional C++. We have lots of functional C++ had in the last years on conferences, because especially the CPP lambdas we got led to thinking about functional C++ and also the multithreading and the stuff that we want non-mutable data led to more functional thinking. We have the design, the talk from Odin Holmes, I think tomorrow, about the modern C++ from Alexandrescu Reloaded. He's doing the more modern style of template metaprogramming stuff, really scary stuff, calling it postmodern C++, though we're kind of getting there. I didn't want to name the talk the right mix of modern, postmodern, functional, contemporary, classical, and what do I know of C++. I didn't want to call it this way because the C++ we use these days, yeah. If you look at modern, the definition of modern in the dictionary, you get relating to the present or recent times as opposed to the remote past. In terms of C++, 15 years ago is remote past, I would say, because the language is evolving so fast that 15 years ago really is in the past. Characterized by using the most up-to-date techniques, ideas, or equipment. So what I think modern C++ is exactly that, using what is available now and how we should use it now. So denoting the form of a language, for example, C++ or German, that is currently used as opposed to an earlier form. Well, and the third one is kind of going back to the art stuff, kind of contradicts the definition of modern art, because here it says marked by a significant departure from traditional styles, a recent style or trend in art. I wouldn't say that, well, if you look at the whole history of art since the year 1000 BC or something like that, then modern art is recent. But if you look at like the last 50 years, then modern art is already in the past. So. I voted using C++ to its fullest. and I gave like a comment, a reply to what I think should be using C++ to its fullest. What we consider best practice today, so using features of the current standards and not using the features that have become obsolete because of the current standards, but also old features. For example, resource RAI is still modern stuff and we should heavily use it. Some people still don't use it enough, in my opinion. And we should combine what we have, the styles we have, to get the best out of the language, to make it cleaner, to make it easier maintainable, but also to get the performance we can get out of it. So get the best of all worlds. So much for modern C++. Some people, for example, my wife told me, oh, if you care so much about this stuff, then write a book. This is what it would look like. C++, the good parts. If I should do a forward, it would start like this, more or less. When I was a journeyman programmer, I would learn about every feature of the language. I would attempt to use all of the features I knew. And I think I was showing off because, well, it worked because when I had learned something new and used it, all the people on the company would come to me and ask me about the new stuff because, well, that was my thing back then, learning the new stuff. Eventually, I figured out that some of those features were more trouble than they were worth. Most programming languages contain good and bad parts. I discovered that I could be a better programmer by using only the good parts and avoiding the bad parts. After all, how can you build something good out of bad parts? It is rarely possible for standard committees to remove imperfections. We know that in C++, they have all the old stuff in it. Well, most of it, they start removing some things now. Because doing so would cause the breakage of all the bad programs that depend on those bad parts. But you have the power to define your own subset. You can write better programs by relying exclusively on the good parts. Sadly, I can't write that forward because someone else already wrote it in the book JavaScript, the good parts. But I think basically for C++, it's more or less the same. C++ and JavaScript developers, they like to bash the other languages, but let's be honest, we have some really bad parts in the language, and the JavaScript people have some really bad parts in the language, and we know it. And we know that we should use only the good parts, but hey. Something similar from Arne Mertz within C++ is a smaller, simpler, and safer language struggling to get out. Okay, let's get to the next verse. The challenges when we want to teach the modern C++. It's a moving target. We get new features every 3 years, plus the technical specifications. So if you want to stay up to date, we have to relearn stuff, we have to get the newer compilers, we have maybe to go over our code bases, throw out old stuff like auto pointer, which is not anymore in C++, and things like that. But besides of the new standard documents, how we understand the language also changes over time, and not every 3 years, but constantly. For example, shortly before C++ 11 came out, there was a book that talked about, among other things, about universal references. A few months later, someone said, well, let's not call them universal references, let's call them forwarding references. Who of you has heard the term universal references before? And who knows it as forwarding references? It's basically R-value references on template parameters. So this was modern effective modern C++ by Scott Myers. I think he published this early 2011 or late 2010. So something else, almost always auto was a style by which was a blog post by Herb Sutter from 2012, where he said, well, we could and maybe we should use almost always auto for type deduction. And instead of writing widget W and with the initialization, we should write auto W is a widget. When I look at modern code, I very rarely see this. And if you look for almost always auto on the net, you see lots of discussions that this is just too strict, too boilerplate. Everybody knows what this means, and nobody wants to read this kind of stuff. So the community kind of said, well, yeah, Herb Sutter is or was the guru of the week, but let's not do everything he's saying. So back then, many people tried it, and then they got back and said, well, let's not always, almost always, but often use auto. One example, I think the only slide with code in my talk, print a map. We get a map with keys and values, and we printed. This is the C++03 version. We made a map iterator from begin and increment it until we reach the end. We get the key is the first part of what the iterator points to. The value is the second part, and then we can print the key and the value. Pretty straightforward, but pretty much code just to print a key and the value. In C++11, it got slightly better. You can just don't have to use the class K and class V anymore. You can just take a map, and for every element in the map, well, the key is the first part of the element, the value is the second part of the element, and just print it. We could have used a class map up here, but then to get the K and the key and the value, we would have to use type name map colon key type and type name map colon not value type but mapped type. So better use this one. In C++17 it gets pretty short. For every pair of keys and values in the map, print the key and the value. Done. And when we get like concepts in C++20 or maybe 23, and we can even get rid of the first line, because then something like map hopefully will be a concept, and we can just say we want a concept, something that satisfies the concept map here, and print it, and that's as short as it can get, I think. So you see like C++03, 11 is like 8 years later, and 6 years later we get even shorter, so let's see what the future will bring. There's one more or many more challenges. C++ runs in very, very different environments. We can have like games computing. There was a talk by Guy Davidson about game programming. We can have like smartphones where we have resource restrictions, or cloud computing where we just don't want to use too much power, or we have tiny chips with almost no memory, or supercomputing, or we have the old style enterprise software from around 2000 where we still have to use C++. And all of these have very, very different requirements. So there is no one C++ fits it all. So it's many moving targets. For example, if we want to do a sales pitch for RAI, the usual example is, well, use, for example, unique pointer for memory management, or lockguard for mutexes, or streams for files, F streams. The usual argument for this is exception safety. Well, if you talk to Odin, who's working on a very tiny chip, they don't have much memory. They don't do many memory management. They don't really have mutexes what they use. They don't have streams of files they want to use, and they have exceptions turned off. So all of this is out of the window. But RAI is still a good idea on those platforms, because you basically don't have to care to write the manual cleanup code. So this sales pitch, what you usually do in most environments, maybe not apply to other environments. For teachers, well, I say teachers, but I mean everyone who kind of wants to transport something about C++, people who write about C++, people who talk about C++, we kind of need to want to keep up with the new standards, with the new ideas about C++, and this in addition to our normal jobs. We have to relearn every few years what we thought was normal until then, because there's always something new, always something we do different now, or we as a community. And we also have to explain to those who we are teaching that these things change. I don't know about you, but I've been writing about a bit over 100 blog posts in the last 2 years, and I don't want to go back and rewrite them because something has changed in the standards, because, well, I can write something like an update below it, so things have changed, don't read this anymore, but it's a lot of work to keep up and also to keep the people that are learning C++ up to the speed of the language. And there's something different. I think many people who learned C++ in the past started at least with C++ 98 or 03. Very many people also start with C first as the basics. If you go to colleges, to universities, still many professors and teachers start with C as the basics and then build up on to learn C++. And then they say, okay, and when you have this, then in C++ 11 we got this feature, and in C++ 14 we got this change, and in C++ 17 we got this change, like layers. But this is not what we do today. We do C++ 17 and the good parts, but not, people don't need to learn the old parts that are obsolete now, so we don't need this thinking of layers, and we have to kind of rethink what we teach. There's also because if we first teach them back then in C, we had this kind of stuff. What the people see first sticks in their minds because they hear it often. And for example, if I talk to someone who is not doing C++ development but kind of has heard C++ lessons in university or in school, and I tell them I'm a C++ developer, oh, pointer arithmetics. No, we don't do that anymore in C++, very rarely. If you do very low-level stuff, we might do pointer arithmetics, but pointer arithmetics is basically C stuff, and in C++ we have iterators and range-based for loops. We don't do that much pointer arithmetics. But this is the scary stuff that sticks in their head, and partially this kind of thinking and this kind of teaching also contributes to the prejudices against C++. This is such a hard language. Other examples are new delete. Many people still learn new delete first, and then, oh, we have smart pointers, and then they get taught, don't use new delete anymore. But you told me I have to use new delete. No, use smart pointers. But what do I use new delete for? You need it at some points if you do your own smart pointers, but not at first. On this topic, there's a very good talk by Kate Gregory from CPPCon 2015, Stop Teaching C, which is basically about this topic that you just should stop teaching C first to build up on it and teach C++. So start with C++, and I don't know if you can read this here. Basically, she lists a chapter of a book. Objects and classes come in chapter 17, because until then it's all C. Operator overloading, chapter 20. Templates, chapter 25. Const, chapter 30. This is all basic C++ stuff that should be in the first chapters. Standard library, chapter 50. The lambdas in chapter 100 or something like that. So you should do this first and then go to the low-level stuff. Start with the level of knowledge that this is basic for the C++ programming, and then go to higher level and lower level as needed, but not start with a low level to build up on it, because you don't need it anymore later. Adoption of modern C++ takes some time. Many people that go to conferences, like you all, belong to this early innovators or early adopters part. So many of us may see lots of people using the new stuff. But if you look into the industry and look at people that are not that visible outside because they don't contribute to the community, they don't write on social media, they don't write blogs, that just produce code, then there's lots of people that are still using C++ 98, still using C++ 03, or basically using C with classes from the early 90s or something like that. Scott Hanselman, I think, called those the dark matter developers, the people you don't see, that you know they are there because there are like 5 or 6 million of C++ developers. But the only thing you see from them is the programs and the code they produce. So I think if you do like a search of if you look how many people are C++ developers on social networks, on conferences, writing blogs and something like that, you get maybe at most about 50,000, which is a really small fraction of the 5 million of developers you have out there. Okay, what resources do we have to learn and to teach C++? Did I tell you already I was a fan of Twitter polls? I got 469 votes, so not that much. But this also has a huge bias. Like I told you just before, the people that are on social networks are likely to learn things differently than most of the developers that are out there. A surprisingly low fraction of people learned most of their knowledge from teachers or professors. Most of them, the people I reach, use books. There is a good part of online tutorials and blogs and this kind of stuff. In this others, please specify, I got like this list. Some read code from colleagues to learn more C++. Some read magazines, which is like, well, we don't have those anymore, I think. So this probably is a bit in the past. Usenet, also good in the past. More books, and someone also conference videos. So let's go over these. Classrooms, so teachers, professors. There are teachers that are really enthusiastic and learn on the new stuff and teach the new stuff. In my experience, you rarely hear from people that have a good C++ teacher, because those people just write C++ for a living and are content and done. You mostly hear from the people that have a bad C++ teacher, because those are the people that turn up on Stack Overflow, on forums, and ask questions. I don't know what I'm doing here, and post some horrible, our teacher gave us this, can you help me? So it's difficult to see how many good and how many bad teachers are out there. But what you see from the bad teachers is basically you have in some universities, you have like the requirement, if you are a professor there and want to do research, you also have to teach. Oh, I don't want to teach. Well, I whip up a representation for a few years ago, and I do this over and over again, and don't even think about adding new stuff from the language. So there are professors out there that still teach C++ from the early 90s. And these produce fresh legacy C++ students. For example, in 2015, I came upon a blog post, "Stop using Turbo C++." I thought, well, I actually gave him a comment. You were writing this in 2015, Turbo C++ was like end of the 90s. You could have done this blog post like 10 or 15 years ago. He said, well, thanks for the comment. I completely agree. But in most of the engineering colleges in India, students are forced to use Turbo C++ in classrooms in 2015. I used well, Turbo C++ was until, I think, 2002. After that, it became Code Gear. After this, it became Embarcadero. So what they are using is a 13 to 15-year-old compiler, and they are forced to use it. I'm not sure if it really is most of the engineering colleges, but even if there's only one college teaching that way, it's really horrible, I think. Well, the next one is books. What is good in, well, this was actually one of the answers to this Twitter poll I made. I think this is a bookshelf from James McNellis, so if you want new hints what you can read, just look at the books, and there's some good ones in it. The pros we have when we read books, the author usually has like some good didactics, one line of thought from start to finish. Usually books are reviewed, not always, especially these days you have lots of self-publishing. I'm currently the technical reviewer for a book a colleague of mine is writing about C++17 STL, and he has like 5 or 6 reviewers, including me, and all I see from the other reviewers, good stuff, nice, there is no review. There are some, you always do some minor errors, and you always can improve the book, but if the reviewers go there, good stuff, and keep on, and this is no review. So you really have to be careful that you get reviewers who really want to improve the books. What is not so good about books, the books last long. There are books out there that are 20, 30 years old. And that content of the books is no longer valid, but the books are still advertised because the companies printing the books still want to make money off it. They don't care about good code, about modern C++. They care about the money they make from selling the books. If you have an error in a book, it's relatively hard to fix because if I have a book, I don't cross-reference to the errata page every now and then. So I read the book, and if there's an error in the book, either I find it or I believe it. And for many students, this matters that books usually are not free of charge, so you have to pay for them. So people tend to not buy the books even if they are good. One effect I've seen from books is a Stack Overflow question from 2013. I have a problem here, and my compiler cries because I use this code, iostring.h, which is like 1996 style, and no namespace std, just using cout, and keep getting the same error when I try to compile it, iostring.h, no such file or directory compilation terminated. Because that's not in the standard. The current compilers don't know this stuff anymore. He's using the book, Teach Yourself C++ in 21 Days. I looked it up. You can still buy the 3rd edition on Amazon. It's from 1999. Blogs and tutorials. If you're interested in blogs, there's a weekly blog roll from Meeting C++ on meetingcpp.com. This is, well, you see, I prepared the talk in November, so it's relatively old. A lot of blogs, it gets longer and longer, the weekly blog roll, so there's a lot of good contents in blogs out there. Well, this content he lists mostly is good content, but there's also bad content out there because there's hardly any review on blogs. Anyone can whip up a WordPress.com page and write what he likes to write about. The pros of blogs and tutorials is that you can get them for free, usually. Authors have the ability to change stuff when they find an error. To be honest, usually we don't look for errors and usually we don't fix those errors. But sometimes if someone leaves a comment on my blog and says, well, you did something wrong there, or this is obsolete now, then I go ahead and either fix the comment, the problem, or write an update that something has changed in the language. What is not so good about books is that they are not that coherent about blogs, is that they are not as coherent as books because, well, like I said, in books you have kind of one line of thought from beginning to end, and in blogs you get like 1 week you get a bit of piece of information from that direction, then from the other direction, and you kind of have pieced your picture together of the language. This is a tutorial from a YouTube video from 2016. Yeah, board and CPP from 1998, iostream.h, conio.h, clear screen, and this is the actual style he's doing. I think he did about 3 or 4 of these videos, and just no explanation, no text, just hacking away in the editor. This is everything that you see. Like, what? Okay. This is another thing. A blog post, string handling functions in C++, through lang, through cut, through copy, through ref. These are the C string handling functions, not the C++ string handling functions. But he wants to use C++. He is using C out here with a capital C, but hey. Also iostream.h, conio.h, string.h, so also this blog post is from 2016, and he's a young boy, who enjoys coding and is passionate to make and break and develop new code. So this is one of these fresh legacy students I was talking about earlier. Reading code and learning code from colleagues. If you want from other people to learn from other people's code how good C++ is done, then obviously those other people need to have written good C++ code. If we don't have a colleague who writes good C++, then we just are learning the bad C++ from our colleagues, and everything like, well, this is, even if they have we have a good C++ coder in the company and learn from him, this is like a bit like knowledge inbreeding. We get no fresh ideas unless someone gets new ideas from outside and brings them into the company and to the other people. So only relying on reading code from colleagues is not enough, I would say. Then there are things like Stack Overflow, forums, Usenet. Usenet, well, the mailing list lang C++ moderators still exist, so and they're still active. What is good on these online communities is that you have a lot of different views and that you can kind of learn new stuff. When you write something that is not as good as you might have thought as an answer, you get the comments that the code can be improved. Even if you are teaching C++ on these platforms, you still have the ability to learn. Actually, most of the C++ I know today, I learned from reading questions and answering questions on different C++ forums and Stack Overflow, but also books. The cons is basically the same as in blocks that you have this very detailed questions and answers, and you have to piece the whole view of the language together yourself. Also, you get very much noise. Every day there's a question like, I want to print a string and it doesn't work because the compiler doesn't see iostring.h. And you have basically to filter all this low-level and beginner stuff if you want to learn more advanced stuff. So it's not sorted, it's not filtered. And you also have lots of trolls, especially if you go on Reddit comments. You basically have to go through them and, well, yeah, this is constructive, this is not constructive, not constructive, not constructive. Well, this may be constructive, but I don't know. It's hard to get by with those stuff. And then there are conferences. The last time I held this talk, I did leave out conferences, and there was like a room full of people shouting at me, "You forgot conferences and conference videos." This is just a selection of conferences I found online. There's a lot more of conferences specifically dedicated to C++, and lots of conferences that are not directly dedicated to C++, but have big part of C++ content, like ACCU. The pro is that usually these videos, you can get them for free. Most conferences nowadays record the talks and put them online on YouTube or Channel 9 or somewhere else. The con is you again get only single bits and pieces about the language. You often have relatively advanced topics. You very, very, very rarely have a beginning topic like how do you do hello world in language X on a conference. Maybe if you have like introduction to a new language, but usually not. And the visibility is not too good, I would say. Well, conferences, to attend the conferences, they are limited. You can like get like, I don't know how many are at ACCU. I think last year in Meeting C++ was relatively big with 600 people, so there are not too many people going directly to the conferences. And if you look at YouTube at the number of views of conference videos, you very, very rarely see a video that has more than 50,000 views. So there are not a lot of people watching these videos, actually. So with all these resources that all have their pros and cons, what would I like to have? What do we need to have even better resources to learn C++? We need to have something that has some kind of authority and visibility, so you can like direct people who want to learn C++, be they if they come from different languages or if they are learning C++ from scratch. We can just say them, go to that page and you will find the resource that you need. We need flexibility and volatility because the language changes. We don't want to have stale and outdated content on it. So basically we need something that is online. And we need a community that maintains the page because with a single author you have this bias, and with a community that you have this healthy discussion about what is new, what should be done today, what is the new style, what is actually the modern C++ style. And I think it's hard also for a single person to completely keep track with all the evolution you have in the different fields, especially if you go back to embedded C++, cloud computing, mobile computing. There's nothing a single person can handle, so you really need the community. What do we have? Since, I think, 2010, we have isocpp.org, which is basically the central hub for C++. It has a forum for questions and discussions. It has a blog where they basically lists new blog posts and new books and conferences and conference videos and such things. We have a lot of information about the standardization process and a lot of links to the different standardization documents and also to the mailing lists where you can send proposals. So basically everyone, I think, can send proposals for new language features. And all this information is on isocpp.org. And they have, I think there were 2 major C++ FAQs in like 2005, 2006. And they have consolidated those, and you can find them also on that page. What we also have is a C++ reference, a really good one. It's an online references for the standard library and for some core language features. But I think if you want to start out with learning C++, having only a reference is not enough. I started out with a reference and it really didn't cut it, so you need more than that. It's a wiki format, so everyone can edit it. If you find an error, you can basically go ahead and fix it. It's relatively up to date. Sometimes for the very new TSs and very new C++ 17 features, for example, they miss some code examples. But as I said, you can go ahead and edit it and add some examples if you have a good one. One of the cons is it has no reading order, so you again have to go like find the order if you want to start learning from it, you have to find the order in which you can read through it. A really good thing is it has executable code, so it's basically linked to an online compiler, and you can take the code examples, edit them for yourself, and play around with the features, even if you don't have a current compiler. The next one we have is the C++ core guidelines. I think the last talk here in the room was by Peter Sommerlet about them. Best practice guidelines, basically, it's an effort by Bjarne Strostrup and many others to get this, to get out this part of the language, the smaller and cleaner language that wants to get out. Relatively new is on Stack Overflow. They have a new branch which is called Stack Overflow documentation, which is different from the usual Q&A style they have on Stack Overflow. Where you can basically write one-page examples about how do I use this feature of a language, how do I use that. It's still in beta. It has not that much content yet. Well, 137 topics when I looked yesterday. It has something, it's also, if you want to get started on learning C++, you can go there, and there's like a topic for starters where you get the first hello world and some very, very basics. What is not so good about it is it has no apparent order. For example, if you go to the topic of rule of 305, then it starts with the rule of 5, then the rule of 0, and it back references to the rule of 3, which comes last. But I think it has potential to get a really good resource. And what is also good is it's community edited, so you can go ahead, place comments on the pages and contribute and improve it. What I'd like to have. Well, this is just a fantasy. This is no commitment or proposal that I want to start something like it. So something similar to the SO documentation, but where you can like go ahead and say you should read things in this order. And maybe with alternatives, so you can basically go ahead and read these pages if you want to go to embedded programming, or read these pages in that order if you want to go to, no idea, cloud computing, or if you have to deal with legacy C++ or something like it. So you can basically compose your books from the pages that are there, that are edited by the community, with those moderated discussions, so like basically an attached forum where you can have the same discussions you have in SO documentation, I would say. And I think that's about it for me now. So what do you think? What are your comments on this? Yes?
So I do embedded systems, and like you say, a lot of my tutors are getting on a bit. They teach a lot of outdated stuff. But to me, so I learned C to start off with, because C is a classic embedded language.
Yep.
You can do it in C++ as well, but use a small language. How would you go about teaching, say, an embedded systems course if you wanted to remove all those bad C practices but still learn the language as well as C++? You kind of have to create that base. You can't avoid really learning some of that layered evolution that you were talking about.
Yes. Well, you can avoid a bit of the layered evolution because you can basically skip the C++ in 88 and 03. Yeah. But I agree that if you have C programmers and you want to teach them C++, that you have to stress the fact that some parts of C are not relevant for C++ anymore. And you have to kind of get rid of old C habits, I would say, like that. I have not really done much embedded programming yet, but I would recommend, there's a very good talks, two talks actually from CPPCon 2015 or 16. I think one is by Jason Turner, where he basically uses C++ 17. It's a live coding where he writes Pong for the C64 in C++ 17, and I think the output is like 1,000 bytes of assembler, which is really great, which is kind of, you can use this to persuade C people to switch to C++ or to consider using C++ to get really efficient code.
Yeah, the classic thing is like
yeah.
C++ or use C because it's much smaller and you can fit more on it, right?
Yeah, but with modern modern compilers and modern optimizers and template metaprogramming and all the compile time stuff you can use in C++, you actually can get better C++ code than the things you have to do in C. Because many people in C would not go ahead and write everything from scratch, and you use macros to get common stuff done, and don't use the specialization you can use for that the C++ compiler will give you. I'd also recommend the talk by Odin Holmes, who does the template metaprogramming for embedded systems, which is really good. He has some, I think the last time I heard a talk from him, he had some benchmarks where the normal C++ version well, his modern C++ version of an embedded program would like perform 5 to 10% better than the actual C version.
Wow.
Björn.
I just wanted to add to, you mentioned Jason Turner's econ presentation. Also follow his C++ Weekly YouTube channel. He does 5–10 minute presentations, often debunking performance myths that exist, especially in the embedded community, about how you cannot use higher level constructs because it costs a lot. And he shows again and again and again how you can take a modern C++ construction that replaces typical C construction, and you get easier to read code that is faster.
Do you know gotbolt.org?
What is it?
Gotbolt.org, it's named. It's basically an online compiler, but currently not executing the code, but it shows you side by side the code and the assembler that is generated by it. So you can play around with kind of compiler switches and this kind of stuff, and basically you write code in one window, and while you are writing on the other side, you get the compiler output, the optimized assembler output, and you can basically see that your 3 lines of C++ code and 20 classes you have before it get reduced to 1 line of assembler or something like that. So it's really impressive to see. That's what Jason Turner used to show these 1,005 bytes of C64 assembler with this C++ 17 program.
What did you say it was?
Gotbolt.org. If you look for Compiler Explorer on Google, you will find it. Yes?
will essentially fragment the field. Instead of teaching C++, you will be teaching C++ online.
I have two answers to that. The first one is depends very much on the audience you have, because if you have an audience that is dedicated to learn maybe embedded C++ with a specific platform, you can cater to that audience. The other one is on teaching C++, I would go for maybe not for bleeding edge C++. For example, these days, today, I wouldn't start teaching C++ 17. I would do this maybe later in the year or next year when C++ 17 is out and you have compilers available. And I would stick to teach the standard C++ that is available on the larger compilers. You usually don't have the problem anymore that it takes years for the compiler to get standard compliant. Sorry? They are getting there. They are not like Clang, like okay, it's 2016. We are standard compliant for C++ 17, but they are getting there. They're keeping up with the pace because of that problem. Because you have those other compilers, and basically they are getting the audience that can do the newer stuff, that wants to do the newer stuff. But you're right, I wouldn't go, like I said, I wouldn't go today and teach C++ 17 and all the bleeding edge and the TS stuff. Maybe have some comments that there is new stuff coming in the next years, because like I said, you have to tell your students this is likely to change next year. But I would try to find some middle ground, something solid they can use on the modern compilers. You also, if you have students and you teach them C++ 14 today, if you go back to an Embarcadero compiler, well, they use Clang under the hood now, but Clang that is like 1.5 or 2 years old. If you go to something like an IBM compiler for HPUX or things like that, they are not C++ 14 compliant. They have maybe some or all C++ 11 features, but they are coming behind. And you always will have this problem that you can't use the modernist or the modern common sense C++ on really every platform, especially if you go to like exotic embedded devices and you have devices that still have C++ 98 compilers. So okay, more comments. Yep.
I've seen an entry on Stack Overflow with basically a curated list of books about C++.
Yes.
With a brief comment saying whether they are up to date or outdated or should be avoided.
Uh-huh.
What's your take about it? Do you think it's useful?
I think it can be useful if it's actually updated. Well, I think I have seen the list. It's a relatively long list, and if you get lower in the list, the question is whether people still go ahead and say, well, the 25th book in this list is up to date or not anymore. And still, if you buy those books, you still have to keep in mind that in maybe 2 or 3 years, the stuff you're writing may be outdated, or the stuff you're reading in the books. For example, the loop over the map example, you get new features and styles change over the time. And in addition to the features, the style that gets taught also changes. But I think it's a good spot to have this list of books. And if someone actually wants to read a book, that this is one of the places I would point them to, because it's community edited. So I think it's also not... you have this kind of community wiki questions on Stack Overflow. I think it's one of those, and everyone can edit it and or propose edits. So it's likely more up to date than some answer that someone has done and abandoned. Okay. So one last question for you. Who of you is currently using C++ 2017? That one I knew. Okay. Productive or just to play around?
Mostly playing around.
Okay, okay.
But it's testing production code with C++.
Okay, okay. And C++ 14? A few more, okay. C++ 11? And who's still stuck with 03 or 98? Okay. Okay, thank you.